Hello, and welcome to this easy-to-understand guide on transistors. Today we will explore what a transistor is, the two main types called NPN and PNP, how they work inside, and exactly how to connect one step by step. We will keep everything simple yet accurate, so even if you are completely new to electronics, you will follow along easily. Transistors are everywhere in our modern world, and they make amazing things possible, like your smartphone playing music or your car starting its engine. Let us begin. First, imagine a transistor as a tiny electronic valve or switch that controls a big flow of electricity with just a tiny signal. It was invented in the 1940s and it changed the world, because before transistors, we used big, bulky vacuum tubes that got hot and broke easily. A single modern computer chip today holds billions of these transistors working together silently. The most common type is called a bipolar junction transistor, or BJT for short. It has three legs or pins, named the collector, the base, and the emitter. Think of the collector as the entrance door, where electricity comes in, the emitter as the exit door, where it leaves, and the base as the control handle that decides how much or how little flows through. Now let us talk about the two main kinds, NPN and PNP. The names simply describe the layers of silicon material inside. In an NPN transistor, the outer layers are negative type material, and the middle thin layer is positive. In a PNP transistor, the outer layers are positive, and the middle is negative. The difference matters for how you connect power. In an NPN, the electricity flows when you apply a small positive voltage to the base. In a PNP, the electricity flows when you apply a small negative voltage or pull the base towards ground. Most beginner projects use NPN because they work well with positive power supplies that we usually have. How does the magic actually happen? Inside the transistor, a small current into the base lets a much larger current flow from collector to emitter. It is like turning a small faucet handle to control a huge water pipe. For example, if 1 mA goes into the base, you might get 100 mA through the main path. This is called current gain, and it is why transistors can amplify weak signals into loud sounds in your headphones. When the base gets no signal, the transistor acts like an open switch, and almost no current flows. When the base gets enough signal, the transistor turns fully on, like a closed switch. This on-off behavior makes transistors perfect for digital circuits too. Let us now do a step-by-step connection example using an NPN transistor to control an LED light, just like in many hobby projects. You will need a 9-volt battery or power supply, one NPN transistor, such as the popular 2N2222, an LED, a 1000 ohm resistor for the base, a 330 ohm resistor for the LED, and some connecting wires. Here is exactly what to do. Step 1. Connect the positive side of your power supply to one side of the LED. Step 2. Connect the other side of the LED to the 330 ohm resistor. Step 3. Connect the other end of that resistor to the collector pin of the transistor. Step 4. Connect the emitter pin of the transistor directly to the negative side of your power supply, which is usually ground. Step 5. Take your 1000 ohm resistor and connect one end to the base pin of the transistor. Step 6. The other end of that base resistor will be your control signal. For testing, you can connect it to positive voltage through a switch, or even touch it carefully to positive to turn the LED on. When you apply a small positive voltage to the base, the transistor turns on, the LED lights up brightly. Remove the base signal and the LED turns off. That is the transistor working as a switch. If you want to use a PNP transistor instead, the connections change a little. Here are some real-life examples to make it more exciting. In your car, the transistor inside the ignition system controls the spark plugs firing at exactly the right moment. In audio amplifiers, transistors boost the tiny signal from your microphone into powerful sound for concerts. Even your computer keyboard uses transistors to detect which key you pressed. And in solar-powered garden lights, a transistor senses when it gets dark and automatically turns the LED on using energy stored during the day. These little devices run our entire digital world, yet each one costs less than a penny. Practice the LED switch circuit on a breadboard, and you will quickly understand why engineers love them. With this knowledge, you can now design your own small gadgets, like automatic nightlights or motor controllers. Thank you for listening and happy experimenting. This has been your complete beginner-friendly guide to transistors.